Well, hi, good morning. Thanks so much for joining me in my shop here on September 12th. It's been a few days since I've been in the shop. A little family gathering thing happening here for a few days, so I'm back in the shop now. And just this morning I posted the last video. I accidentally forgot to post it shortly after doing it. So the last video you watched was done a few days ahead of when I posted it. Here I am trying to remember everything. Yeah, that's what happens when you get a little up in age. You spend a lot of time trying to remember. Why did I come in this room? Why am I here? So, I ended off the last video with the conclusion that trying to restore this coil, not really possible, or this transformer, not possible for me. Suppose you could experiment a lot, making windings, doing stuff, but I think in the end you wouldn't really get all that far. So these coils are wound very, very carefully to achieve specific, let's call them operating conditions, specific impedances and things like that. And any disturbance in the coil is going to throw that off. And it's kind of a knife edge arrangement. So when you slide off the edge, you go down a long ways. The solution I'm proposing here is essentially bypass the whole transformer. The secondary coil would still be in the circuit, and we'll look at the schematic in a moment and consider what's going to happen here. But I haven't put a permanent wire in, mostly because I wasn't back in my shop, and it's just as well I didn't put a permanent wire in yet. I think we need to experiment a little bit. So what I'm trying to achieve here is any level of performance at all. As the radio stands now, with the coil the way it is, and without this jumper in here, there is no AM radio to be had with this guy. With the jumper here and a fairly strong antenna, you can hear something. Now, in my shop here, it's almost impossible to test these things effectively because there's so much interference here in my shop. We really have to take this radio literally outdoors to really get a good feel for its operation. I may end up doing that, but not today because it's raining today, so I'm not going to take that outdoors today. So what to do? The next stop is we'll look at the schematic, consider the situation, and then we're going to do some testing and experimentation to try to determine what the best resolution here is. Maybe a wire isn't the best thing. Maybe a capacitor connecting these 2 points together would be better. I don't know. We'll have to just kind of fool around and try to figure this out as we go, to try to gain, just to get the best performance possible in a radio that has a burned out coil. So let's go look at the schematic here. Okay, so the transformer we're fooling with is this one here. And this coil, by my investigation, is the coil that is damaged, burned, shorted out of the picture. In fact, it appears to be shorted straight to ground. That's what it appears to have happened. Oh, we have a cat calling me. My proposal is to take a lead from, well, basically to move this lead from here to here and abandon this burned coil. It would just be hanging here doing nothing, and feed the signal straight onto this wire, which heads up right to the grid of the mixer tube. The difficulty here is this is a tuned circuit. You tune it once in the factory, actually, at the end of making the radio. This piece here is adjusted to cause this transformer to ring, or to be resonant in the appropriate range of frequencies you want to tune, which is the AM band. It's not obvious, but the AM broadcast band actually ranges over a large change of frequency. The other bands, not so much. Some hardly at all, like the higher shortwave bands. Really, relatively speaking, you're hardly changing the frequency as you tune through them. But on the broadcast band, you're going from 500 to 1500. That's a factor of 3. So trying to make these things operate or provide some kind of resonant benefit, if I can put it that way, that crosses the whole band is a little tough. So one way you do that is you don't make this very sharp, a very high Q. transform. Maybe a lower Q transformer, give you a little bit of boost over a range. Another thing you can do is you can try to make this tune as you tune the radio. So this would be a capacitor hooked up to the main tuning capacitor, and it would change as you go. But that's not what's happening here. This is the main tuning capacitor. It is what's happening here. That's exactly what's happening here. This is the other part of the main tuning capacitor, which is changing the oscillator frequency for the local oscillator. Right, what was I saying there? So the difficulty here is if I move this wire over here, that'll detune this circuit. It'll detune the whole front end of the radio, if you like, on the broadcast band, and you won't have the benefit of a resonant circuit here. The ultimate result of that is just much lower signal applied to the grid, and probably a lower signal relative to the noise. So you're still going to get lots of noise through here, and so you're going to end up with a noisy AM radio reception, except for the strongest of signals. And how strong? I don't know. That's what I don't know. How am I ever going to judge that? So what I want to do is I want to make this connection temporarily, so I can make it and break it, not with a long clip lead, but with a shorter length of wire, the kind of wire that would be in there in the end, because that length of wire can have an effect. And maybe even stick some capacitors in here and see what happens. Oh, so what kind of capacitor would you want? Well, look at this one. This is a tiny little capacitor. Normally this is a very high impedance circuit. Well, it is, if this is resonating. So if this is tuned like it should be, it would be if the coil weren't burned. This would resonate in the range of frequencies that you're interested in, and the impedance of this tank circuit would be high. And so the grid would see the high impedance at those resonant frequencies. The other frequencies outside, well outside of the resonant area, which is the AM broadcast band, would see pretty much short to ground through the resistance of this coil. If I throw this off by hooking up the antenna, that's going to disappear entirely, that resonant effect. If I stick a capacitor in here, that sounds like a really good idea to me, but I can't explain exactly why. The antenna itself is a capacitor. It's a lousy inductor, but it's somewhat of a capacitor. So, but it's a capacitor out in the universe. It's not inside the radio. I don't know. Experimenting, I think, would be the only thing. Tiny capacitors might make a difference. You could maybe make this thing resonant sharp. Have a sharp resonance out of this thing by accident. I don't know. Lots of room to experiment here, because I don't know. Interesting. Okay, I think that's basically the story there. Experiment away with it. Okay, I think I'm ready here. So what I've done is I've arranged a wire antenna. This blue wire is leaving my shop, going out a window from the room next door, and just throwing on the ground outside, because I'm too lazy to try to hang it up at this point. But at least it's an antenna more similar to what this radio would operate with in its usual home, as opposed to the cable antenna, the antenna I would use, which has a long coax lead and all this other stuff. It's a very, very different kind of antenna. So this is just a straight wire antenna. I'm going to turn on the radio. We're going to see what we can pick up with it. Probably nothing, but we're going to give it a go. And then we're going to start fiddling around. Let me turn this on now. Get her going. Okay. Did that really come on? We'll find out in a moment. I also have a a capacitor box here. This is the crazy thing to hook up to a circuit like this, because look at the size and the bulk and the leads. There's the radio. But we'll try this. So we'll replace the jumper with the capacitor box. But first, with the jumper in place, just as it was before, what can we receive with this radio? Are we definitely on the broadcast band? Try that. Okay, so this meter's doing nothing. It's not even switched on. Okay. What do we get? So only hope of getting stations is down in this area. Really. Okay. Very weak. So there's a number of interferences there, and I've gotten familiar with the sounds of them. One is that rapid clicking. Sounds like engine ignition noise. Comes from a source, I don't know what. Comes and goes randomly, I don't know why, but it's quite strong. There's another sound in there, a rumbly sound, which I heard go by briefly. You know what? This wire is going to short on the chassis here for sure. Wow. Because it's not shorted now, but man, it's just a fraction away. Pull it out. That's the antenna wire. It's almost touching right here. Okay. We're sidetracking observation. So what do we got? We got a receiver that's really good at receiving the noise and has no particular, as I would guess, no particular resonance in the front end to help out. Now we'll try to see if we can make that happen by using this box here. Fat chance on this, but you know, this is where the fun is. So okay, disconnect this. You can see the radio went quiet because now it's got no antenna. This could be connected here at the antenna connection point. It's the same thing electrically. I'm going to put it in here for some unexplained reason. Okay, so that's from here. Okay, try not to contact anything. Down to here. Okay, we can hear it again. Let me turn it up a bit. I do have my signal generator at the ready here. I just haven't employed it yet. Just listening to the noise level going up and down. 0.001, but don't believe these numbers. I don't think this is accurate. Quieter? Quiet, quiet, gone. What it would sound like to me is that there is no magic capacitance. Just the greater the capacitance, the more signal gets through once you get up above this level. Say, once above this level, that's a very small capacitor. You might as well just hook a wire up. That's what it seems like to me. Okay, that experiment's over. It did make a difference though. I'm surprised at that. No need for a capacitor. Next experiment here. I'm going to put this clip back in because I don't want to put a permanent wire in yet. I think you could think of this as just more antenna. It's just this time it's inside the radio instead of out there. It's something you don't want, that's for sure. Okay, the radio's receiving again. Something. Now we'll put on the signal generator here. Let me just move this aside. Okay. So the signal generator is hooked up to the loop antenna, which is up hanging on my wall there, that racetrack looking thing. Okay, so the signal generator is going to broadcast a signal, not a strong one either. And we're going to try to pick it up with the blue wire that's laying on the ground in my backyard. We'll see what happens. Actually, any signal from the signal generator is going to be picked up somewhere in here. The wire outside won't matter. Are we ready? Sure. Let me just move this here. The radio is currently tuned to around 700. I'm going to tune it way up to around 1 million. You're quiet, right at 1 million. This is at 1 million. Okay, this is a very, very low signal. There's some hope here. That's all I got here. This is the whole kit and caboodle combined. Just in case the range is way out, we'll move this up even higher. 1100. Not happening. Okay, we're going to couple the antennas a little closer. Like, how about this? Like, how about that? Try once again. Oh boy, this is. You would really expect it to do something now. If I got things right, 11, full blast. Wow. Okay, I would have been really expected to act. Let's do this now. Without connecting to the metal of the antenna wire, I'm just going to clip the red lead onto the insulation. I'm going to clip the black lead onto the ground. This will make a difference, I think. Having this on there, maybe. Didn't seem to. Okay, so it's just a poor man's capacitor connection here. Is that going to do it? Oh my gosh. No. Okay. Back down the power. We're going to make a direct connection onto the antenna here. Radio's gone a little quiet because it's a low impedance. I've hooked up a low impedance to the antenna. I've sort of shorted the antenna out a bit with the signal generator. I've turned down the output on the signal generator. There it is. About 11. Now, let's see if we can find a little quieter spot. No, there's no such thing in here. Go down to 1 million just because I like that number. There we are. 9.5. Oh, that's exactly what it's tuned to. Boo-boo there. There's 1 million. That's 1 million. Okay, now because I have a lot of experience using this signal generator on all kinds of radios, I have a pretty good feel for what a strong and a weak signal is. This would be a very strong signal from a decent antenna. It would be similar to this. And this is connected straight onto the antenna down here. And how good is that? It doesn't sound very good to me. So the swooshing sound is because there's other signals, interference signals, that are just about the same strength as the signal generator signal. Very, very, very weak front end. We need to compare this now to what's happening with the shortwave band. So bearing in mind I've got this guy going at the, let's see, 1000 times 10 is 10,000 microvolts on the antenna connection here. 10,000 microvolts. Sensitive radios can pick up, really sensitive ones can pick up 0.1 microvolts and resolve it. Except for the noise that would be there. So we're going to knock this down. 10,000, 1,000, 100. So it's 100 microvolts now. Switch this over. Short wave. Right now we'll tune to 10 megahertz. Okay, we're at 10 megahertz. We'll go up there to 10 megahertz. We'll check the signal level here, or the output level rather. Calibrate it. 10 times 10. 100 microvolts or something like that on the antenna. Pretty quiet, isn't it? Not an impressive showing here. Yeah, that's a little better. I like hearing the hiss. Okay, so that's what the radio's doing with 1/100th of the signal the other band was trying to work with. And it's about the same, right? It's better. Okay, that's now 1,000th of the other signal, or 10 microvolts, roughly. Now that's pretty good for a radio like this. See, either the mixer or the detector is adding in a lot of noise as you tune in. I think that's where all the hiss is coming from, I think. But that's not bad, because that's a very weak signal. A more typical antenna signal that you actually try to sit and listen to, like something maybe from North America on shortwave, would be much more like that. That would be not even a really strong signal. That's really good. So the radio is very capable. The signal's not getting into it from the antenna on the broadcast band. My putting of a wire in here, not helping out too much. But I was sure I picked up one station barely last time I tried this. But I think these experiments really prove out that this solution of just hook up the antenna to the grid basically is what I would be proposing here. Not going to work unless I can. And this can't be bought. Oh, you know what we can do here? You know what we can do? We can stop, drink some coffee, and then come in and experiment with the SDR radio and try to see the resonance, if there is such a thing, on the front end of this radio the way it's working now. Sounds like fun. You know how when you get an idea, it seems really good at first, but when you go to implement it, you end up realizing, maybe not the best idea in the world. But here it is. So what I've done is, this is the pickup coil for my SDR radio. If I touch it, yeehaw, lots of noise to pick up. All that stuff you see up there is all noises that are being transmitted or produced by mostly little power supplies and other dumb things here in my house that, okay, let me just quiet that down. Oh, I stopped it. That's not quite what I wanted to do. I just want to turn the speaker off so we're not listening to it. Okay, so the radio's not operating because all I'm fooling with is the very front end, the antenna coil. There's no reason to have a radio operating for this. In a good radio, the antenna coil will resonate at the frequency you've tuned in, and you can take, you know, your SDR pickup coil. This is just a coil of wire in here. It's nothing fancy at all. Put it near the antenna coil, and without getting it too close so as to affect the operation of the radio in a serious way, you can get enough signal into here to show up on your SDR. Now the trick of this is in the background, just an element of this. I have a sweep generator running. It's not putting out any signal right now. It's turned to 0. But in a moment I'm going to use this to cause a signal to sweep through the band, through the broadcast band. I'm going to do it pretty quick, really quick. What that'll do on the SDR display, the SDR is just a special radio receiver, is you're going to see that signal, and you can be able to start judging what you're hearing coming out of the speaker of the SDR versus the amount of signal I'm putting in with the signal generator versus those noises. Are those noises so strong that they cannot be overcome, or are they actually so weak that any little signal supplied to a radio is going to take over? That's kind of the question. I already know the answer. The unfortunate answer. So, but the real idea is the sweep is being put into the antenna of this radio. So the sweep is being passed through the antenna coil, or maybe in this case near the antenna coil. So I can still pick up the sweep using this, and we can see if there is a resonant point on it. There won't be, because there's nothing here to resonate anymore. But in a good radio, this kind of test, you'll actually see a bump. Let me use my mouse here. You'll see a bump. It looks something like this bump, or maybe like this one, maybe a little broader. And as you tune the radio, the bump will travel up. Everywhere the bump goes, the signals are boosted relative to the noise, which is the whole idea of the front end. Get the signal stronger relative to the noise. So, and this has worked really well with a number of radios I've done. It's not going to work well with this one. So right now I have the coil in place. I'm going to start the sweep signal going, and you'll see the chart lift up, so to speak. Here we go. Okay, now remember, this radio's not on, but I'll turn the speaker on this other one here, the SDR, the computer radio. Okay, you don't need it too loud. I'm going to turn the output down just a wee bit here. So now when you look at the SDR, you see this rise. This is the start of the sweep. The sweep signal starts here and travels all the way up, well, somewhere up around here. I think I have it set to about 1600, so it should be stopping in here. You can see it quite distinctly here. I have a hard time recognizing where that lift is under all this stuff. Let me give it a little more potency here. I kind of see the edge here now. But at this point I'm putting a pretty strong signal out of that signal generator to achieve this. Now, is there any resonant point in this guy here? It's bouncing around, by the way, because the SDR is trying to it's got its own automatic gain control, and that bobbing you see is the gain control trying to keep up with this sweep. I mean, this is not built for this kind of work. The SDR is meant to be just a radio receiver. We will tune the old radio and see if there's any bump that can be identified in there. And I'm sure there won't be. If there is, I'm going to be really stunned. This can be very hard to do. The bump can be very shallow. Sometimes the best way to see the bump, there's no bump here to see. There's nothing happening here. Sometimes you can see the bump by looking at the peak of the signals that are there, even if they're noise signals. But here's my point. You see, I'm putting a strong signal in, and pretty much here it's winning the day. It's just about overcoming the noise signals, but not down here. These guys are really, really strong. They're really, really powerful. And what it is exactly, I couldn't tell you. It's something. So let's turn the sound off. We really don't need to listen to that. That sound, by the way, is the buzz of the sweep going past the tune point of the SDR. See where the red line is here? Every time the sweep crosses this line, there's a little pop in the speaker. It's happening so often, the pop becomes a whir, bzzz sound. So that's what we were listening to. I can slow the sweep down so you can see it. Maybe I'll just now you can see it going across. Speed it back up. Well, this hasn't proved anything other than it's just a reassuring that there is no resonance in the front end. Everything indicates, and it should be the case, that there's nothing resonating in the front end. The secret then would be to use a resonant antenna. So we're going to try that secret next. Will a resonant antenna correct all this? Well, maybe what I should say is compensate. Compensate. So the lack of tuning here will take place in the antenna itself. We'll see how that works out. Okay, let's give this a try. Well, I need the radio on for this. Did all the other work I was doing with this radio today. Just checking. I never put it on full power. Experience tells me it wouldn't make any difference. Once you get up around 90, 95 volts with a radio like this, it pretty much performs the way it would perform. Maybe a little quieter. Put it on full voltage, you get a little more volume, but functionally it's the same. Let it warm up here for a bit. We'll talk about the antenna. So here's the loop antenna we're going to use. It's a fairly inexpensive antenna. I'm not trying to market or promote this, but I think it's pretty popular. It has an output jack at the back, wires coming around and hooking up to the antenna of the radio. Now, why is it so quiet? Let's make sure it's on broadcast. Yep. These antennas are very quiet. They are, to some degree, to the radio, they're a little bit like a short circuit. Not quite. It's very low impedance, but in place of that low impedance, which is killing the life of the front end of the radio, it provides a strong signal because it's resonant. And this is how you tune it with this. Hear it? Isn't that like magic? Nothing? Something. Now, we'll put this at 590 with some luck. See how it just faded right out because the antenna needs to be tuned? Play me a little 590. 590 is the strongest AM station around here. It could be the antenna's in the wrong direction. Put 590 on the dial. I'm going to move the loop. So these loop antennas, they don't really boost the signal so much as they are killing another signal. They have a very deep null in them. And if I aim this at the noise source, I can null it right out. But at the same time, I have to have it aimed. I can't have the null pointing at the station. So, it just depends how it just depends. Just depends. Let's go a little further away here. There we go. I wonder if you could triangulate the source of the noise by doing this kind of thing very carefully. Okay. Bad antenna connection. That was with 95 volts. Wait a minute. Took that back up. Strange sounds there. Okay, we'll go like that. Full voltage.
Vehicle discount and a home deductible assurance.
It's better. See, to get rid of that noise, there's the station hidden under the noise. So this is actually a noise blocker the way I'm using it. Okay, let's go for the toughie. We're going to try to tune in 860, I think it's 860, which is another AM station. Somewhere around here. Around here. My hand is interfering here. Maybe if I just null the noise. Well, I'll be, as soon as I ground myself to the radio, I'm no longer a source of noise bringing, like my hand here. Yeah, right. Looking for a French station. Okay, out of the range here. I'll hold the antenna this way and try it. No. That could be I've nulled out the station. The radio's tuning was pretty accurate the way I remember it. Okay. Hey, where'd the noise go? The noise is gone. It's mysterious, boy. Wow, let's get it. Come on. No, it's back. If it sounds like I'm just muttering aimlessly, it's pretty much what's happening here. I don't think it's going to come on. Okay, another possibility down here around 740. Another kind of weakish signal. Well, I think this is enough of a demonstration here for sure. I'm going to try one more, 680. It's a popular news station. Okay, I can't resist after having done all that. I have another loop antenna, great big one over here. I gotta try that. We're gonna leave it tuned just as it is. I'm just gonna switch antennas and see what we get. I'm gonna turn the volume up here. I'll do this live. Okay, find this cable. That's about the best we can do with this antenna arrangement. Okay, I'm going to get the other one. Okay, this is the other antenna. It's a biggie. It's a big guy. That's the loop here, disconnected, ground, and the other wire. Okay, this loop is also tuned, so I'm going to tune it. And we'll see what happens here. I happen to know the preferred direction is something like that. I'll tune it.
Team and potentially his new shadow cabinet. Parliament returns September 20th. Cormac makes Sweeney Parliament Hill.
City News Time, 10:37.
Remembering Queen Elizabeth.
Thousands are paying their respects to the Queen in Edinburgh, Scotland today. People were lining city streets as the Queen's casket made its way to a cathedral. Our Moment Qureshi is following that and joins us live with more moments.
Irene, the Queen's body is now lying inside that cathedral at St. John's Cathedral in Edinburgh, Scotland, after making the long but relatively silent journey along the Royal Mile. It was quite a thing to see. They walked for about almost 2 kilometers with the Queen's coffin in the hearse going slowly through the streets with a full royal guard, and her 4 children all walking in lockstep behind, including King Charles III. He was also dressed in full military garb as they slowly made their way through the streets, and thousands of people were lined up. But you could really hear a pin drop that was completely silent as they wove their way through the streets to St. John's Cathedral, where they are now. And so we gather to bid Scotland's monarch, whose life of service to the nation and the world we celebrate, and whose love for Scotland was legendary. Let us worship God.
Okay. There's a station, another strong station called at 640, but there's a noise signal right on top of it usually. Can't hear it at all. On 590. I need to tune my antenna. Okay, give it a tune.
Possibly, given the fact that the line is so shredded, this being really the only thing I'm doing good to. I think performance-wise, we have Stanton doing Stanton things, hitting balls all over the yard, hitting home runs. That would help it be a little harder to watch judge a big spot. You got a Hawks and Carlos Stanton.
590.
Big time since he's left-handed. That would mix up a couple of righties, because you might as well as anybody. When righties are struggling, you can get them out the same way you get the righties out the building. It's with 2 pitches. So, again, how much pressure does Aaron Boone have on him? You know, you talk about first place.
Okay, I think I finally got somewhere. I think, the solution here is the internal antenna coil is shot. So if you connect an antenna that essentially is the same sort of thing as the antenna coil, you can kind of restore the radio back to its former glory just by bypassing that transformer coil. Maybe not quite its former glory. If this coil were working properly and you used a loop antenna, you would get two bangs for $2 out of that. You would actually work fine. Well, I think that's it for today. I did notice this wire is really bad here. That's a bit of a problem to try to fix, but maybe I can come up with something. Sleeve it or something like that. And because I don't want to get in here and try to replace what's back here. I think we're right at the end of the road here with the radio at this point. Now it's a question of a few other things like light bulbs. What are we going to do there? You need lights on this guy to make it really look beautiful with the proper lighting. Okay, anyway, thanks a lot for watching. Hope you enjoyed that. I hope you enjoyed that. And I'll see you on the next video.